My name is Khalid Al Mulhim. I'm a Saudi Aramco engineering consultant, working for almost more than 25 years, specifically in the HVAC specialty. I would like to take this opportunity to thank the organizers and the professionals that have attended and shown the interest in this particular session, which shows really collectively how much we would like to be aligned with the Saudi 2030 vision. We all know HVAC systems account for a significant share of electricity consumption in our residential and commercial sectors, as Saudi Arabia continues to move boldly toward the Vision 2030 objectives that embrace greater sustainability, lower carbon emissions, and smarter cities. Our HVAC industry has an important role to play. I'm looking forward to sharing insight, learning from your perspectives, and hopefully leaving this room today with stronger collective motivation to accelerate energy and refrigerant transition across the kingdom. Thank you again for being here. Let's get started. Today, I'm excited to walk you through a topic that previously provides practical savings, demand control, ventilation, in commercial buildings, especially in Saudi Arabia's unique diverse climate. This presentation will explore the energy efficiency, economic benefits, and demonstrate its alignment with the ambitious goals of Saudi Vision 2030. Our objectives for this presentation are threefold. First, I will demonstrate the energy efficiency potential of demand control ventilation in commercial buildings across 4 major Saudi cities. Second, I will present the result of a detailed economic analysis, including the return on investment for implementing this technology. Finally, I will quantify the environmental benefits, especially in terms of carbon reduction. Crucially, this work is deeply aligned with Saudi Vision 2030. It directly supports the Saudi Green Initiative carbon reduction goals, enhances energy efficiency within the commercial building sector, promotes economic diversification through the adoption of innovative technologies, and contributes to the sustainable development of our cities. So what is exactly demand control ventilation? In simple terms, DCV is an intelligent ventilation strategy. Instead of supplying a constant flow of outdoor air, it automatically adjusts the air intake based on the actual number of people in the building at any given time. This is typically achieved using carbon dioxide sensors, which act as a proxy for occupancy level. Here is how it works. CO2 sensors continuously monitor occupancy in different zones of a building. This data is fed into the building automation system, which then dynamically adjusts the ventilation rates. During periods of low occupancy, the fresh air intake volume is reduced, and when occupancy is high, the fresh air intake volume increases. This is to ensure we maintain optimal indoor air quality while minimizing energy consumption, without violating the minimum indoor air change rate for the building space part. The key benefits are significant: substantial energy savings, reduced operational expenses, improved indoor air quality, a lower carbon footprint, and even an extended life expectancy of the HVAC equipment. To quantify these benefits, we conducted a study based on a hypothetical but representative case. That's a lawyer term. We modeled a 13-story office complex with a total area of 50,000 square meters and a full occupancy of 2,750 people. Our analysis was performed for 4 distinct climate regions in Saudi Arabia, namely Riyadh, Jeddah, Dhahran, and Jazan. The HVAC system modeled was a dedicated outdoor air system with specific performance characteristics. We also use a variable occupancy schedule reflecting typical buildings' usage pattern, with full occupancy during standard working hours, reduced occupancy in the summer, slightly, about 20% reduction, and minimal occupancy during off hours and weekends. Our methodology was rigorous and based on established industry standards. It is based on the 2025 ASHRAE Fundamental Handbook chapters that focus on psychrometric for air properties, as well as cooling load analysis for ventilation. We used actual hourly climatic data for all the 8,760 hours in a year for each city, sourced from a reputable and credible source, CAPSARC, and validated using other sources as well. Psychrometric calculations were performed in accordance with the 2025 ASHRAE Fundamentals Handbook. We compared two scenarios. The first is a baseline case with constant ventilation and a case with demand-controlled ventilation, ensuring that the minimum ventilation rates specified by ASHRAE standard 62.1 were always met. The economic analysis was conducted over a 15-year life cycle using a commercial electricity tariff of 0.30 Saudi riyals per kilowatt. This is very conservative assessment. This is very important element. This is, before I go to the result, I need to show the outcome for Riyadh. This is for the hours of the week during the first week of July, which is supposed to be the peak sensible load for Riyadh. Basically, you see two lines, and there is a space or a shaded yellow. The shading yellow, this is where the energy is being reduced according to the analysis. And that continues. If you look on the right, you could see a chart for the entire year for Riyadh, and you could see that for a system without a demand-controlled ventilation versus demand with a system with a demand-controlled ventilation. It's important to note that during the peak summer times, you get the maximum benefit of the demand-controlled ventilation. That's the results specifically for Riyadh for that particular week. I'm going to go to the next, where I will show you the result for the four assessed cities. Here are the results of our analysis. The findings are compelling across all cities. We observed energy saving ranging from 12 to 14%. This is translated into substantial annual cost saving from over 57,000 riyals in Riyadh to more than 236,000 riyal in Jazan. And why is that? Because Jazan is challenged by two: high ambient temperature, high sensible temperature, and high latent load. The payback period for the initial investment is remarkably short, ranging from just under 1 year in Jazan to about 4.3 years in Riyadh. The 15-year net present value is highly positive across all cases, indicating strong financial returns. Furthermore, the environmental benefits are significant, with a total annual CO2 reduction of over 1,300 tons across the four cities, driven by the lower energy consumption, which is equivalent to taking approximately 283 small vehicles. This is the sensitivity analysis that touch base on the relative humidity, and I believe this is very important. As the relative humidity goes higher, we could see that the annual energy saving is increase as well. So there is a correlation between the relative humidity, the higher relative humidity, the higher humidity, the higher saving for this particular technology. Now, if we are talking about another technology, like for example, the air side economizer, it's going to be the other way around. The lower the relative humidity, like the case in Riyadh, we will have the highest saving. This is another look of another sensitivity analysis that touch base on the impact of occupancy patterns on energy saving. So if you have a building of, like as stated, 13th story highs, and you have only one shift and they work for 8 hours a day, and the remaining hours, I would say 80% of the people are not within the building, it's a good system that you need to take a look at and assess to achieve the potential saving, especially for areas where there is high sensible dry bulb temperature and high wet bulb temperature, like Jazan, for example. This is another sensitivity analysis that touch base on the 30 kilowatt or 30 halala per kilowatt hour of electricity. And this what's important of this. If you are negotiating with the owner of the building and there is some feed that there will be an increase in the energy in the future, you could utilize this, that the payback period will be reduced as the energy tariff rate increases. Based on these findings, we have several key recommendations. First, we must promote awareness among building owners, developers, and HVAC professionals about the significant benefit of demand-controlled ventilation. Second, we strongly recommend including life cycle cost analysis in the tendering documents for all new commercial constructions to lock in long-term savings. Third, it is important to consider other complementary technologies such as air-side economizers, which can work in conjunction with demand-controlled ventilation to achieve even greater energy savings, particularly in drier and more temperate climates. Finally, while our study shows great promise, it is essential to conduct a specific analysis for each building to validate its unique performance potential. In conclusion, our study demonstrates that demand-controlled ventilation offers a powerful solution for improving energy efficiency in Saudi Arabia, commercial building sectors in specific. We found significant energy saving of about 14% on average, with rapid payback period of under 5 years in all locations. The financial returns are robust and the environmental impact is substantial, aligning perfectly with the goals of Saudi Green Initiatives and Vision 2030. The compelling business case for demand-controlled ventilation implementation warrants serious consideration by all stakeholders. We urge building owners, developers, and policymakers to embrace HVAC viable technologies, not just the demand-control ventilation, to capture these significant energy, economic, and environmental benefit for our beloved kingdom. With this, I conclude the presentation. Thank you very much.